we shall start another data structure. It is called queue. So, today we shall cover about this data structure first, and then different operations of queue. Mainly the operations are called enqueue, dequeue and status. It is just like push pop like, and then we will try to cover different types of queues. So, different queue structure, those are extensively used in many program design, and finally we will conclude this lecture giving hinting some application of queue structure actually. So, this is the topics for today. Now, let us have the concept about queue. The name queue is very common in our daily activity. So, we usually if visit any counter, so you have to be in queue like this one, right. So, queue is there, right. So, queue means it is basically some order. So, here as I have mentioned one example. So, it is basically customers standing in front of a counter, actually there is a queue of customers. Now, so this is the usual. Now, there are some applications also available when you are writing some program, particularly in a distributed computing environment where many client programs are running and there is a server which has to serve different clients actually. So, that client server computing where we have to maintain that which should be CPU should be given to which client alike. So, they are basically all the clients should be queued, that means they are in queue, and then server will process each client according to the queue. So, you know queue is because first who basically appear first should be served first, and that is why stack for example is called LIFO, last in first out, but here queue is called FIFO, first in first out. So, who join the queue first will be served first. So, this is the concept it is there. Now, so there are many other real life application where the queue is there. For example, there is a traffic, right, and controlling the traffic. So, for a better control of the traffic, and there is a automatic traffic controller, if it is there, they basically allow you to follow the queue concept, so that the traffic can be better managed or controlled. Anyway, so many applications here and there actually, like stack is also extensively used to solve many algorithms. So, queue is also very much important to solve many programs actually. Now, let us decide in what way queue is different from the other data structure that we have learned so far. Now, like stack or array or linked list, it is also an order collection. So, that means all elements are in order. Order means in which order they added into the list. So, that is the order actually. Okay, it is not that sorted order or random order actually. Okay. So, it is an order collection, and like stack, array, linked list, it is also homogeneous set, that means all elements should be of same type, but there is a basic difference between the stack and queue. Stack allows operations at one end only, whereas queue allows operations at two ends. So, there are two ends in queue, one end is called the front and another end is called the rear. So, if you want to perform removing an item from the queue, then it should take place from the front of the queue. On the other hand, if you want to add an item into the queue, then you should do it rear end. So, there are two. So, front is just similar to we can say bottom, and rear is basically you can similar to top in case of stack it is there. Now, regarding this removal operation, actually it is called the dequeue operation, and similarly removing inserting an item into the queue, this is called enqueue operation. So, this is the two name is given instead of pop and push. Like pop and push are basically is a marked operation for stack, right. It is not usually followed to mark operation for deletion and insertion in case of queue or other structure like. So, it is customarily used the different method to make it distinguish that these operations are basically is a standard operation or marked operation for a particular data structure. Anyway, so insertion and deletion, namely the enqueue and dequeue, these two operations can be done at two ends like rear and front, and as it allow to remove an item based on the property or policy called first in first out, this structure is also called the FIFO structure. Just like stack is called LIFO structure, it is called the FIFO structure. Now, let us come to the discussion of how a queue can be stored in a memory for your program. Now, you can use either array or linked list, any one. Array is very convenient, very simple, so you can have it, but array, if you use array, suffer from the limited size. So, that is why it is a little bit okay, it is not this, it is encouraged to have it, but linked list represents the best representation by which a queue can be maintained. So, today we will discuss about first the array implementation of the queue. Array implementation of the queue or array representation, 1D array is required. Now, here you okay, in this figure as you can see, this is the total size of the array that we are considering. Now, because of the operation as going on, so it is not that front is always here, rear is always here, because these two pointer can move both way. I mean, this front always move in this direction, rear also moves in this direction. This because I am sorry, the front is front is move in this direction, rear is move in this direction. It is basically the idea, it is there. Okay. Now, so while you at the very beginning you can start, while you are starting the operation, both are basically front and rear at here, front and rear are here, and when queue is full, then you can see front is here and rear is here, right. So, that basically gives you an idea about whether queue is empty or it is full. That can be decided by knowing the location or pointer or counter value of the front pointer and rear. So, front and rear are the two pointer to indicate the frontmost element and rearmost element on the queue. You understand? So, this is the concept, it is there, and this is an array of size queue. So, we can say total capacity of this queue, that means using one dimensional array representation, is n actually. Now, sometimes it may have that the front and rear are same. So, it indicates that there is only a single element there, but this element can be at any position of the array. So, those are the very things to be taken into care when you consider about array representation, but all those things are not coming into linked list representation because it is most convenient way anyway, but array representation is simple. So, that is array structure is there, but it has to be taken care many things while you implement the different operations on it. Now, so I told you linked list representation is the most suitable for a queue representation. Now, again question is there whether single linked list or double linked list. So, here the idea is that double linked list should be followed to represent, to maintain a queue, because here you can see both the pointers front and rear should move both direction. For example, whenever you want to add it, so adding go on adding list in this direction. So, basically when you go for enqueue, so it is basically enqueue is equivalent to insert at end, if end is the end of the list actually. Okay. So, this is the idea, and when you go for removing, the removing is basically delete at front. So, this is the two operation for the linked list is sufficient to maintain a queue, and if you want to move here in this direction, both direction, so double linked list is there. Anyway, so single linked list or double linked list is better, that is why Java developer follows for stack queue implementation double linked list, but any single linked list also can be used, but you have to be taken care about how the movement, if you want to do the backward movement and everything, you cannot do that. Anyway, so double linked list or single linked list, that is not an issue actually, but linked list is an important one data structure that also can be considered to build another data structure called the queue. And here operations are two end, rear and front, that is end and front. End actually the insertion can be taken place, and at the front you can make the deletion of the item, it is there. So, this is the idea about the linked list representation of queue. Now, we will discuss about operations of queue. First, we will discuss few operations using array, and then finally, we will be there in the linked list. As you know, so operations are pretty simple. Operations, okay, there are three types of operations like enqueue, dequeue, and then status. Status representing size, availability, empty, all these things are the same thing, just like stack is only there. So, enqueue is basically insertion, dequeue is for deletion from the item from the queue. Now, I will just give an idea about array, it is very pretty simple. So, you just simply pointer, two pointers are to be maintained there. So, the pointer is called the front and rear. Rear pointer is basically says the location of the array where the elements are to be added, and then the front is basically from where the element are to be removed. So, this algorithms is given to you, you can just follow this algorithm how the how enqueue operation can be there. So, before going to enqueue operation, you have to check whether we have already achieved to the full of the array. Actually, full of the array is basically, I mean full of the queue is basically marked with whether rear position come to an end of n, that means that is the total bottom of the array actually you can say. So, if it is there, then we can say that queue is full. Now, here you can see queue is full does not mean that all the elements in the array are occupied by the queue elements, because say suppose in some situation rear is at 5 and queue the front is at 5 and rear is at 10. So, you can say that 6 elements are there, but suppose total capacity of the array is 10. So, rear is at 10 and front is at 5. This does not mean that array is full, because 6 elements are there out of total 10 elements, but 4 elements are somehow we will not be able to add, because if some element comes there, then we can go on adding, it is like this. Now, if it is full, then definitely the enqueue operation will fail, otherwise this is the operation that you can do it if rear equals to 0 and front equals to 0. This basically express one extreme condition that it is basically queue is empty, and then in this case front equals to 1 and rear will be rear because it is 0, because there is no elements are to be there. Anyway, front equals to 1 and rear equals to 0 in that case. Now, okay, once you do insertion there, so front will be increased by 1 and then rear also will be incremented by 1, because insertion takes place, and then if we want to go for removing an element, that means to perform the dequeue. So, dequeue will takes place from the location 1 only, and here we are assuming that array index is starting from 1 to n like. Okay, if you 0, then accordingly the index and the assignment will be there. and here is actually queue rear is the item to be inserted there. So, using this array actually, and if you follow this algorithm and you can go on inserting elements into this enqueuing into this, you can see it actually how it works. Anyway, so this is the enqueue operation. Like enqueue, the dequeue operation is also there, and this is the algorithm for dequeue operation, just similar to here. Now, before performing dequeue operation, you have to check whether the queue is empty or not. So, queue is empty when front comes to 0, that means there is no more elements to be removed here, and if front equals to 0, then queue is empty. Otherwise, you can come here, queue front, this basically empty, the elements to be removed. So, take the read the elements at the front location, let the element be item, and then if front equals to rear, that means so rear position and front comes to the rear, we can say that elements the stack become exhausted, queue become exhausted. So, if it is exhausted, then we can set the rear equals to 0, front equals to 0. So, again queue will start from very beginning like this one. You can consider the situation of queue in front of a counter, like it is like that. Okay. And then otherwise you can see front can be increased by front equals to 1. So, front go on incrementing this one, and this is the end of the things it is there. So, here actually idea about this one that you can do it, how the dequeue operation can be takes place. Okay. So, this is the dequeue operation. And this is the operations with array. The another operation is size, empty and everything, just only front and rear pointer and everything, simple arithmetic that you can follow to check that whether a queue is empty or a queue is full or a queue contains n number of elements, etc. So, those are the simple arithmetics for the stack for the queue having the locations of the front pointers and rear pointers. So, this algorithm you can follow to understand that how it work. Okay. Now, let us proceed with the discussion about for some other so linked list based implementation. We have discussed about array implementation. Now, linked list using linked list, how the queue can be maintained, let us discuss about it. As I told you, so if you use linked list and if you want to perform insertion, then insertion should be at end, and if you want to perform dequeue operation, so dequeue should be at front, and this way we can ensure first in first out what is called the policy. Now, here is an example how the insertion at front and insertion at end and deletion at front can be done. We have already learned about while we are discussing about the linked list structure. So, these are the few pointer manipulation that you have to do in different situation like queue is empty, and you can see that knowing the front and rear pointer, actually you can check easily whether queue is empty or queue is not empty, and in this case full condition never achieved because it is dynamically grow to infinite length until memory is not available like. Okay. So, this is the case that you can think about whether the queue is empty or queue is full in this structure. And I do not want to discuss about the insert at front or delete at end, all these things are there, that is the obvious insertion we have already experienced with while we are discussing linked list structure, even the double linked list also no issue. So, this is about operations with linked list structure, representation of the queue, and this is the status of the queue, and they are basically indicated by the front and end pointer or front and rear pointer you can say. Now, there are many variations of queue structures, those are for different application it is used. We will discuss about the different varieties of queues there. Let us first discuss about circular queue. Now, circular queue is basically is an okay, you probably know circular linked list. So, it basically from an end, if we want to go to front, then actually the last node, that is the endmost node, should not include the null link field actually. Rather it will point to the header node or first node, you can say header node. So this way a circular link can be maintained. Now if we follow a circular link, for example for an array, in order to implement the queue operations, then such a queue is called circular queue. So typically a circular queue will look like this. So circular queue, you can note, as I was telling about, say front is at 5, rear is at 7, it indicates that only few elements are there. Now suppose front remain in the same and then go on adding, that means rear is increasing. So one time rear will come to an end where n is the total number of elements available, okay, so I mean size of the array. So after that you see front at the front for first 5 elements, I mean 5 locations rather, fourth location we can say, is remain empty, but still if we want to add few elements you will not be able to add, because stack is showing, I mean queue is showing as full, because rear reaches to an end. But it could be occupied, those are the non-empty location or non-occupied location which are at the front position. So the idea is that whenever rear reaches at this end, but still at the front some elements are available, we can move the rear to that and go on adding this one. It is same also front also. So this way front and rear, instead of going to an end marking, it can loop to a circle. So if we follow this kind of logic in order to represent a queue, then this structure is called queue structure, and logically a queue will look like this, is a circular ring like. So the queue will go on, and for this circular queue now you can decide whether a queue is empty or not. So queue is empty if rear and front both are say -1 like. Otherwise queue will be containing some elements, and the number of elements will be decided by the simple arithmetic between rear and front pointer calculation. So this is basically the idea about it, and that is the circular queue concept, it is there. So circular queue concept is basically used for the computer science students to as a puzzle like, because how we can do, whether insertion, where it will go, so lot of questions, particularly if you are preparing for gate and everything. So many questions usually posed related to the circular queue concept, because it is a little bit complex in concept, complex in pointer manipulation and everything. But anyway, once you understand about it, logically a circular queue is just like a basically circular ring sort of thing, but only the thing is that movement of pointer needs to be taken care, in what way, in what direction they can move, and how many elements are there, and which is the current location of front and rear. Those are the basically systematically you have to follow, and if you do it, your programming is become very easier actually. Okay, so this is about concept of circular queue. Now operation of circular queue, you have to have the enqueue and dequeue. I will not go for detailed discussion about it. You just have given an idea about algorithm here. I advise you to check the algorithm and try to implement by writing program, and then you see whether this is working in a circular fashion. And if you implement this algorithm for the circular queue, it is called the enqueue, circular queue, CQ, and then you can compare the enqueue operation for non-circular queue representation of array, then you can check it how it is working there and there. And so this is the idea about, I just left as an exercise for you to have it the real programming, and you can check it. So this is the circular queue, and the next varieties of queue, okay, circular queue, enqueue and dequeue operation, just is a dequeue operation you can follow. Status operation also, how many elements are there if given a rear location and front locations like in a circular queue, simple arithmetic calculation, you check that what should be the arithmetic calculation between the two and everything. So, it is just like rear minus front minus plus 1 minus 1, whatever it is there, you check it and then you can find how many elements present there. So, you can write on pen and paper also, practice it, just calling some enqueue and dequeue operation at random and check it. I will give the programming in the next session for implementing all these things, then you can understand that how a queue can be implemented using Java programming, and that idea of implementation you can extend it to different type of queues actually, and then you can have the idea about it. Now, so this is the one idea about one type of queue, it is called the circular queue. Other than circular queue, some other type of queue is also has some importance, they are called double ended queue. Now, the concept double ended queue also it is called Dequeue. Coming into the concept is that, now in case of ordinary queue that we have learned so far, the insertion can be taken place at rear position and deletion at the front position. But double ended queue is a special type of queue where both insertion and deletion can be taken place from either end, from front and rear end. So, if it is like this, then it is called the double ended queue, and in this picture as you can say, this is the rear end where both the insertion can be taken place here, and this is the front end, here is there. Now, that there may be some reason, some situation where you have to have the insertion and deletion at the both end, that that is why it is there. It look little bit chaos, but it is actually not chaotic things in that situation, because in many application it may takes place. But actually, although it is really chaotic, I understand that it is chaotic. So, in order to make it little bit stringent, so there is a computer science concept it is there, let us restrict to the insertion deletion, let us allow it, but not that both the operation at both the end. So, this way we can have some restriction. The restriction can be in two ways, one is that input restriction and then output restriction. If you restrict the input, then it is called the input restriction. That input restriction means we do not allow to do the input at the front, only deletion will be there, and then at the rear end both insertion and deletion can take place. So, if it is like, then it is called the input restricted dequeue. On the other hand, there is output restricted dequeue, as the name implies, you are allowed to do insertion only at the rear end. However, you can do insertion deletion at the both end. So, if you do so, then it is called the output restricted dequeue. Now, obviously, there are certain rationale behind this. I do not want to discuss exactly why all those input restricted dequeue and output restricted dequeue. For all those things you can have the detailed discussion in several textbooks on the subject, you can find it. Anyway, other type of queue is called the priority queue. Now, priority queue is also like a random queue sort of thing, because here in this queue you this queue structure policy will be allowed to remove from any location of the queue actually. Now, if you do it, then it is the priority queue. Now, again the problem is that in which location you will be allowed to remove an item. So, for each item there will be a priority to be assigned. So, the item which needs to be removed not necessarily from the rear pointer, but it is from anywhere in between front and rear depending on its priority value. That means, highest values of the priority will be removed first. So, this is the concept, and it is little bit, if you see in that stricter sense or stringent sense, that FIFO structure will be violated, because it is not strictly in the first in first out manner actually, but it is in a priority manner. Again, if the two elements are having the same priority and they are of highest priority, then which element are to be removed? So, this element should be removed again first in first order. So, if the two things are of the same priority, but the one is who came first, that will be, that means which element is basically in the rearmost will be removed first actually. So, this concept is called the priority queue. So, priority queue, as you know, implementation of enqueue and dequeue operation become complex, but if your logic is clear, and then all those things will not be a difficult things, it is there. And for priority queue implementation, there are, if you use array and everything, once you remove one element from the array as it is from in between intermediate one array intra element we can say, then lot of movement are to be followed. If you remove it or if you add one element according to the priority, add it, so lot of movement it is there. So, that is why array based representation to implement priority queue is not a good idea. Linked list may be a good idea, but there is a better idea that is available using matrix representation. What is the matrix? A matrix basically maintains a number of arrays actually. So, each row basically maintains the priority for each. So, here 1 to n different priority. So, if an item reaches to a queue, right, and which having priority I, so it will hit to the ith array, and each array again maintains rear and front indicating which thing is there. So, this is one good solution, that a matrix representation of priority queue is good, but it has limitation is that sometimes an array can exhaust it, and if it is an exhausted and a particular element of a having a particular priority queue for which that array is exhausted, you will not able to add it. So, this has limitation. Now, there is a better idea, obviously using linked list, because it dynamically grows, it can add, but it can add according to the position. That means, whenever you want to remove can be rear and front, but here priority whenever you want to insert at the end, and that insertion in the order, that sense that according to the priority value it will be inserted. So, it is basically element will be inserted in the sorted order of their priority value. So, this means that those are the elements which are the highest priority, they will be towards the front position like. So, front to rear, if you sort it according to the descending order of the priority value, it will work for you to implement priority queue. Now, there is a better one structure which we will discuss in details while we will discuss another data structure called tree. So, using tree based representation, a priority queue can be implemented. As this concept will be discussed in details later on. So, I just want to skip it for time being, I do not want to discuss in details here, but I want to say that priority queue is basically a concept of heap, and a heap can be stored in an array actually. So, a priority queue means heap, or priority queue is basically array based representation, but it is again priority based queue implementation, where an element will be removed or added according to the priority from the queue. That will be discussed in details later on. Now, application of queues, let us come to the application. I will not discuss the details about the application here, but there are many applications. Those are basically for system level programming. If you want to write program for compiler or operating system or game design or some other window programming and everything, or client server computing, there you have to follow queue structure. Like say simulation, which is very much common in mathematical research or research oriented study, there you can use queue. CPU scheduling, which are required for client server programming or distributed computing or multi-threading, you can use. Process scheduling, again this is a multi-threading programming or concurrent programming in client server environment, you can use it, and all those discussion really very advanced level. So, I do not want to discuss in this course also, this course beyond this course all there, you can have more idea about this queue structure in details, because I could not cover so many things in details, because the topic is too exhaustive. So, I should suggest you, I recommend you to go through this book, where a detailed discussion about the queue structure you can find in chapter 4, and you can learn more from there. And in the next video, we will discuss about how a queue can be programmed using Java, because Java programming can be little bit hands on for you to have the details idea about it. So, that will be the next video lectures we should discuss. Okay, thank you very much.